And welcome. Thank you all for joining us. We're in for some learning a whole bunch of really cool stuff today. Before we get underway, I'd like to begin by acknowledging and paying my respects to the traditional owners on the lands on which we meet today, with a special heartfelt respect and acknowledgement to the Wadawurrung people, who are the traditional owners here in Ballarat, where I'm presenting from today. I'd also like to pay my respects and acknowledgements to the Indigenous elders past and present. And hello, and welcome to the first in a series of 5 workshops looking at HERE technology. Yeah, really tongue-tied today. Anyway, looking at some of the HERE technologies, really cool tech that they've got alongside some of the IBM Cloud offerings. So we've got about 166 toys in the toy box. As I say, being a developer, they're all toys. Like, build some really cool stuff. Gonna grab a screen share in a second. Sam, could you share screen, please? Sam has the slides. Sneaky. Hey, there we go. Thanks, Sam. And here's Sam from HERE Technologies. So we've got this really cool function.
Are we recording, Developer Steve?
We are recording.
Fantastic.
We can edit this bit out. It's fine.
Okay.
We got this really cool new function we're trying to. So if I do this, the slide will change. There might be a delay in the slide changing. Anyway, we're in for an amazing time. We'll edit that part out too. But yeah, as I said, welcome everyone. Amazing that you could join us. We hope that you learn a whole bunch of really cool stuff. And also, I mean, more importantly, just geek out with everyone and get hands-on with some of these tools. See, that was a Jedi wave. The delay is happening because of the lag. No, let's not go there. Anyway, so normally when we're running IRL events, there is some housekeeping. So I thought it'd be fun to also have this slide. Also, we really like that GIF. That GIF is one of my favorites. Anyway, if you don't know where the toilets, we've been working remote all year. If you don't know where the toilets are for now, please find them. And I'm sure you know where all the exits are and everything. But we are going to go. This is a sound effect that goes with the Jedi-ness. We are going to go through the virtual venue. So if it's your first time visiting, welcome. We've been using this a whole bunch throughout the year just to run events because it brings back some of those nice aspects to in real life events. As if you've been to one of those before, people get to hang out and be able to talk to each other. You can jump around different tables, as you've probably already seen when you came into the venue. You can talk to each other. There's text chat if you don't want to put your camera and microphone on. But please, feel free to just connect and geek out. That's one of the things I think's been really, really missing. I don't think Sam's watching the screen. Click. Each table has separate sessions. So unlike, normal WebEx video style streaming, you can actually jump around and have separate conversations with folks. Also, each table does have whiteboards, so you're able to draw and do all sorts of fun, amazing things. Hidden tip, with the whiteboards, you can actually put a whiteboard inside a whiteboard. It's a little bit meta and a whole lot of fun. So check that out after we've finished with the workshop today. Yay! Also, there's a number of different floors available. So if your tables do get full on this floor and you want a particular table set up, you feel free to jump to the other floor. The best part is you don't have to walk up or down the stairs. So there is that. Amazing. Maybe you can just click it. Yeah, okay. And of course, it works on a whole bunch of browsers. Now, just a little disclaimer to that. The mobile version of this platform, if you try to use that, you will probably get a notice to say that it is in beta. It is indeed very much in beta. So it will kind of work depending what browser and what phone you're using. Just a heads up. You can, one more. Yeah, thank you. And of course, we've got a code of conduct in place. Basically, just be cool with everyone. We're all here to learn stuff. We're all here to connect. So yeah, just keep that in mind. But I know you're all amazing and we'll definitely know that one. Let's go next. Thank you. And he's the amazing host that we're going to have. Well, I like putting tags on myself, wasn't it? He's the host we're going to have anyway. And here's Sam. Sam's already in here. Gloria, one of my colleagues. So I'm one of the IBM developer advocate crew in the Australian New Zealand area. Hello, developer Steve here. And also Vedan's going to be doing talking today primarily showing off some really, really cool code stuff. But yeah, we'll all be around in the next 5 weeks of sessions. Oh, there's Vedan. Yeah, say hi. There's Drew. I don't even know what that sound effect was just then. So as I said, we've got 5 weeks of workshops coming up. Today it's all about location services with HERE Tech. It's literally just an introduction. What happens when AI, so the second one's about AI. The third one, IoT, one of my favorites. It's going to be using this amazing little thing, but we're going to get to that in not this week. Then we have one on blockchain, which is amazing. We ran a IBM developer meetup last night on blockchain, had some amazing discussions, and everyone always wants to learn about some of the blockchain stuff, especially all the big open source things. Anyway, we won't get into that today. And then the one of my favorites, well, I mean, they're all my favorite really, but Node-RED. So getting hands-on with Node-RED and location services. If you haven't seen Node-RED before, it's open source, drag, drop, low code, no code, open source platform that we have. Think of Scratch, but with more coding if you're familiar with Scratch. So anyway, we will get onto that one, not this week, but stay with us. So they'll all be in this same venue. So once you've already registered and set up, you're kind of good to go. See, the swoopy noise makes more sense. No, don't go anymore. Don't go anymore. Anyway, well, without further ado, let's get underway. Over to you, Sam. Oh, one last thing. Wait, I feel that was a bit of a cliche with the tech industry. One final thing. One more thing. No, I was good for us. If you've got any questions as we're presenting, or you want to ask something, there is a Q&A section on this screen. So as you can see in this view here, that's got chat participants and Q&A. So you can ask it in the general chat. Also, side note to that, HTML tags work. So including one of my old favorites, Marquee. So if you want to ask a really fancy question, you can get it to animate. All the Q&A section as well, and we will be keeping an eye on the chat. So anyway, over to you, Sam.
Thank you very much, Developer Steve. Can you hear me okay? Just give me a feedback. Can you hear me okay? Okay, great. All right, with no further ado, let's kick this webinar going. Oh, we got Sean on board now. Yeah, okay. There are a bunch of random people are coming to the presenter mode. Let's get this one started. My name is Sam Amir Brahimi, and I'm the Developer and Community Relations Lead for HERE Technologies here in Oceania. And with me today, I've got Vedan Bansal, who is representing our global developer relations team, and he's residing in India. So welcome him to our event. And I also want to welcome everybody from different parts of the world. We realized like it originally was an Oceania event and became an APAC event, and we are now receiving participants from all over the world. So I welcome you guys, and I say good morning, good afternoon, and good evening to everybody. Okay, so today's webinar will be the first webinar of this series, and we're going to set the scene for all the location services that we're going to use in the next few webinars by introducing the HERE technologies and its location services and APIs and SDKs. And I'm going to give you a quick intro on the HERE technologies in the beginning, like who we are, what we do, and where we stand. And afterwards, I'll take you through our location tools and services specifically for developers and give examples. And at the end of this section, I will have a surprise for you. So I'll keep it to myself for now, and I'll reveal it afterwards. And finally, before we get to Q&A and wrapping up, Vedan, my colleague, is going to take you through an application development demonstration, and he's going to build a parcel delivery app from scratch using JavaScript and HTML, and our REST and JavaScript APIs as well. All right, with no further ado, let's kick this one started. All right, a bit of background about HERE Technologies. We're the world's leading location data platform owned by pretty much a group of German car manufacturers like Audi, Mercedes-Benz, Daimler, and alongside Bosch, Continental, Intel, Pioneer, and other companies like Mitsubishi and NTT Data as well. So we are owned by a number of well-known organizations, and we're supporting them with their businesses through location data and services. And at the same time, we have a lot of other partners and customers that I'll talk about later. In summary, I'd like to tell you about our vision and mission, which is essentially to enable an autonomous world by building a digital representation of the reality and complete data ecosystem through HERE platform that allows data providers, consumers, developers, and all sorts of people and players to work hand in hand in addressing real-world problems through the power of location, information, and services. So, well, our company's history began with the automotive industry. That's where our origin is, and we were building highly accurate maps for navigation in the beginning, which led us to be purchased by a consortium of German automotive companies in 2015, which I mentioned. And with location growing in many industries, the company is now growing with a greater focus on technology. This essentially has led us to further involvement in consortium with other large companies such as Intel and Bosch and Pioneer and all those guys that I mentioned. And we have key users and partnerships like Esri. If you're in the spatial industry, you recognize their name, Amazon, Oracle, SAP, and our beloved IBM as well. So that's a bit of a background about the company. And I want to mention that for the third consecutive year, we have been sitting on #1 spot in the world. You understand, like with all the players that like some of them are listed on there, it's a tough competition, and we've been the #1, which is due to the completeness of our data as well as the highest quality data and services that we provide. If I want to give you a bit of give you a summary about the company in numbers, we have mapped over 200 different countries, and we've got more than 9,000 employees around the world in 56 countries that we have offices in. Pretty much 4 out of 5 in-car navigation systems in Europe and North America and elsewhere, they are using our services and map content within those systems. And yeah, that pretty much adds up to over 100 million vehicles, and that number is increasing on a daily basis. We started from 1985, and that pretty much is 30 years, adds up to 30 years plus of experience in this industry and providing contents and maps and location services to a variety of customers and users of ours. We collect a lot of information from a fleet of 402 cars that are equipped with LiDAR, 360 degrees cameras, and all sorts of sensors that they're generating, in addition to all the other data sources that we have we acquire from elsewhere, add up to 28 terabytes of map data that constantly get updated on a daily basis and gets refreshed and given to our customers. And in that sense, like, we want to make sure that this data is reliable and usable for different use cases. So that was just a bunch of numbers about the company, and this is just a subset of all the organizations that we work with. And if you look through the list, you may find a lot of them familiar. And yeah, we work closely with all of them. And yeah, we form partnerships, and we get data and services from them, and we provide a lot of location data and services to them. So yeah. Okay, that was a bit of background about HERE Technologies, but my main focus today will be to introduce you to all the cool tools and location services that you can access through HERE Technologies and build cool applications or enrich your existing applications that you may have already. So oops, sorry. At the moment, we have over 260,000 developers directly accessing our location services and data. In addition to that, through other platforms like Microsoft Azure and AWS and all sorts of other cloud platforms, we have additionally 3 million indirect developers that are constantly using our services, and all in all add up to over 80 billion API calls a month, which, yeah, it's quite a mind-blowing number when you think about it. And in terms of the industries and markets that our developers developed up for, you're looking at automotive industry, transport and logistics, disaster management and public safety, retail, finance and insurance, healthcare, supply chain and fleet management, and so on and so forth, which don't get into the details of that. I'm sure you can relate to some of those applications that require location services for. With that bit of background about our developer stuff, I want to get into the sort of like dive deeper into what sort of services that we offer. And here's a snapshot of the portfolio of APIs and SDKs that we have, and you can use them as REST services or within JavaScript code of yours, JavaScript APIs. And we have APIs and SDKs, software development kits for iOS and Android at the same time. And you can access these APIs through Flutter as well. So just to summarize, we have APIs and SDKs for interactive maps, geo-visualization services, places and points of interest and search, geocoding, traffic, routing and navigation, fleet telematics, APIs. We have tracking and positioning. We've got weather APIs. We've got transit APIs like public transport, advertising data services, indoor venue maps, visualization and rendering tools, as well as like custom location and advanced data sets, which I will take you through these services in a moment. But I just want to give you the big picture, what we're going to talk about today. So why don't we just start simple, and I will introduce you to our HERE map APIs. As I mentioned, we have over 28 terabytes of data constantly gets fed into our maps and enriches and refreshes that on a daily basis. So you're looking at a very high quality, up-to-date map. And in terms of the coverage, we have over 200 countries covered. And the good news is you're not stuck with like just pretty images or maps that like HERE technology designs. You can customize them, and I'll get into that in a second. So we're going to talk about interactive maps, map images, tiles, map customization, and geovisualization services today. So I guess we're all quite familiar with interactive maps, static maps like that. You can't do much with them. They're becoming quite extinct. Everybody expects interactivity. You want to zoom in, zoom out, pan, and change the layers from the map view to satellite view, add traffic and traffic incidents, and a whole heaps of other stuff. So you can do all of those things with our maps. And you can access these maps through simple JavaScript and REST APIs that we provide. So I mentioned about customization. We have content of our maps as vector sort of content. And with that, it allows you to customize our maps using what we call HERE Map Style Editor. It's an online tool that allows you to make changes to the current style and save it as a YAML file. And basically you will be able to see the changes that you're making in real time. And look down here, only 2 lines of code. You reference to that YAML file and set the style of your map, which will probably take about it will take only maybe 4 or 5 lines of code, and you can turn it into something exotic like this, or make it like a very nice map that is pretty easy on the eye. So that's the power of HERE maps. And at the same time, beside the vector maps that we've got, you can access the pre-rendered maps and tiles through REST and REST APIs and mobile SDKs. And you can take a snapshot of the map at a particular location and send it and share it with your friends that for example, hey, this is where I am, come and meet me. You can do it at a specific location. You can grab that image using a bounding box, which is essentially a rectangular sort of indication of where you want to look at on the map. You can map an image with an address, for example, saying, that's Downing Street number 10 in United Kingdom, and yeah, that's my house, and you can upload it to your website as, for example, this is the address of my business. You can create an image map using proximity circle, like maybe it can be a representation of, let's say, your cell reception, or like the average sort of accuracy of like I reside within this vicinity, when you don't want to share your exact location. And also you can share map with polygons, route, and turn points. And I really like these turn points that you can just grab the image. If you're building a navigation application, you can grab this image pretty quickly and pop it on the screen for the user to know, like, oh, this is where you turn. And yeah, basically notify them about that. And also you can do picture-in-picture like this here, and do other cool stuff with like add lines and navigation routes that you want to share with others, and points of interest that you have as well. So, and these just take a few lines of code as well. And one of my favorite set of APIs are the geo-visualization APIs. You can create custom markers and icons. You can have a look at here. This is like an icon of the sea in the city of Chicago. You can add PNGs, SVGs. You can add YouTube videos being played. Like if you want to, like if you have, for example, a surveillance camera, you can put it there and like show it live as like on the map as people are interacting with it. So you can have animated markers. For example, if you're building a navigation app, or you want to show where the locations of planes are and in the sky, you can create that and show the real-time location of your assets on the map using the animated markers. One of my favorite services is the heat map service. And so basically you create a heat map of, potentially can be the density of the location of certain features. In this case, in this example, is the location of cafes and restaurants somewhere in Germany. You can have dynamic clustering depending on the level of zoom and interaction that you have with your map. You can group and cluster information and points of interest, as you can see here. And last but not least, you can have statistical graphs. Like, for example, this can be the number of votes in Finland that people have gotten, or the population of certain cities. So the bigger the circle, the bigger the population or the number of votes for a certain party. And there are other sort of styles of maps that you can create as graphs as well. One of the other cool features that we have, so I'm going to pause this, is the embedded interactive venue maps. You can create a indoor map of a shopping mall or a conference venue, and you can embed it in an already existing map. And basically, you can interact with it. In this video, there's an example of a shopping mall. As you can see here, there are different shops and retail shops that you can click and get more information about. And at the same time, if it's a multi-story building, you can create sort of items here that you can interact with the map. And this was just a simple example, and you can embed a whole heap of complicated indoor maps, like the map of the airport, as you can see here, that can be the basis of other functions, like as indoor navigation and positioning, which it can be a bit complicated for today's conversation, and I'll skip that for today. But if you're interested, we can talk about it afterwards. All right, that was a summary of the map APIs and SDKs that we got, or the examples as well. Let's get to places, search, and geocoding. We have points of interest and landmarks and location places that we have them in different categories, and their number added up to 55 million of them worldwide in 237 countries. So it's pretty comprehensive when you think about it. And you can browse them, discover them, look them up, and also use auto suggest, like which I will talk about more in the next slide. And we're looking at forward and reverse geocoding, which I will explain to you in a second as well. And when you're looking at doing multiple geocoding, you can run batch geocoders and do geocode millions of addresses and locations in one go. I'll get into that in a second. So in terms of the places and points of interest, let me quickly check if I'm still online and I'm talking to you, not myself. Yeah, so in terms of browsing points of interest, you can filter location, roads, POIs, and others using their category, name, or given their geolocation as well. So you can specify one or more of these categories, and the service will allow you to browse through those things, and you can then grab the information about these points of interest and visualize them on the map, or do other whole heaps of other stuff with it. So these categories can be dining, sightseeing, religious places, natural and geographical features, transport stuff, and so on and so forth. And from a certain location of yours, you can access this information up to 250 kilometers. This is a very simple REST API to browse certain categories, which their numbers are here. If you look at our website, you will have access to all these different categories names, and you can specify them here. And this is the output that it gives you: the position, the name, the country, the address, and other relevant categories that they exist, the phone, the opening hours, and so on and so forth. And once you grab this information, then you can do whole heaps of stuff with it. We have another function called Discover, and it enables you to find points of interest using either a free-form text or a structured text, which I'll show it to you in a second. And you can search and discover known places using this free-form or structured text. It can be partial, just give the country or the street, or you can provide a whole complete name and the address of that place, and you can discover these locations. Or you can search unknown places just using category, let's say restaurants, or just give me anything within close vicinity, like within 5 kilometers or 500 meters of me. And the spatial query part can either be a single location, like I'm at here, like using this, like look at this example, this is the coordinate, and the discovery function is looking at the restaurants. And if you want to provide more context, it's getting the country code as USA as well. Or it can be a circle, a bounding box. It's a rectangular sort of geometry that people that use to like specify the geographic extent of a geographic extent, or even a country. And that's the Discovery API, and it gives you the similar output as this one. And there's another API that you can use to look up some of the points of interest and locations that you've already found, and you know their ID. So if you want to save yourself time discovering new stuff, if you know the location's ID, you can just grab them and use the information provided as a response. The other service, which is again one of my favorites, is the auto suggest. For example, if you want to validate an address at the checkout point of your website, as the user inputs their address, it interacts with a text-based engine to provide suggestion based on the user's input. And you can call the REST API just like this at this particular location, and it basically it requires a base or it's sort of a geographic context, and looks for that thing, and for example, and you provide a query, which is that user input, and the query in this case is res, and the system should automatically suggest restaurants. And once you get the result of the auto suggest, it either gives you a href, which is a link, as you can see here. There should be an href, and you can use that to discover these sorts of categories or places, or it gives you an ID, as you can see here, to look up that address and get the information. And as you can see here, like you can see it in different map providers' websites, like different maps that you can search for REST, as you can see here, and it provides REST areas, restaurants, all sorts of different results, and you can select them and pass on to another API to grab information. In terms of geocoding, I promised to explain it to you. So geocoder is essentially a simple service that translates an address, a landmark, a place that you describe, to its corresponding coordinates. For example, if I'm looking for, let's say, Statue of Liberty, and automatically this translates it into the API translate that, because it's a known place, it translates it into its corresponding coordinates in America. And the HERE geocoding API provides an indication of the relevance of that place that it found the coordinates for, and also the level of confidence, that how confident it is that this coordinate belongs to that particular description that you provided. And you can also do single geocoding, as I mentioned, and a batch forward geocoding as well. So millions of addresses you can do in one go. And this video provides an example. For example, in Australia, I want to set the result language as English, and I'm searching for 10 Amsterdam Street, which is essentially in Richmond, and it's the headquarters of HERE Oceania in Australia. And yeah, the example provided an example of the HERE's auto-suggest as well as the geocoding. So it suggested it, I selected it, it copied the full address, and like it passed it on to a geocoder, which I grabbed the coordinates and visualize it using a marker on the map. And on the other hand, we have a reverse geocoding, which pretty much does the reverse. You pass on a set of coordinates, or like one coordinate pair, and it will provide you with one or more relevant addresses, place names, or whatever that corresponds to those coordinates. And also it gives you a confidence level as well for you to make a decision which one of them would be the most relevant, or leave it to the user to make a decision. That's my address, for example. And this is a quick example of the geocoder. That with the reverse geocoder, not only you can do points of interest, like point-based features, but you can also do streets, you can also do postcodes, countries, and area-based or polygon-based features as well. So in this case, we're gonna click on one of the roads, and it gets the coordinate of that road and grabs the street that coordinate is on it. And as you can see here, it's the Farmer Street in Melbourne. And this is another one, which is Burnley Street that I clicked. And you can get the features as well. Okay, regarding the geocoding, there's another popular example is what three words. For those of you who are not familiar with what three words is, that like somebody came up with the idea of, in case of using complicated addressing systems, why don't we just divide the entire world into squares of 3 meters by 3 meters and assign them 3 random names, like you can, or words. And using that, you can get the unique cell, the 3 meter by 3 meter cell, and you can pass it on, and people can grab the location. For example, this place on Carter Street. The unique identifier, the 3 words are order, reach, and circle. And if I go to and use the here what 3 words reverse geocoder, I pasted it without those slashes, and it behind the scene, it translates that into a valid address within Australia. So you can work with these services on humanitarian sort of use cases, for example, in areas that they don't have access to much technologies and you need to deliver resources like foods and medical support. You can quickly use these sort of services to do that. This is another quick example in Christchurch that we want to get the coordinate, click on the map and get the coordinate and return the nearest admin boundary. And you can use that with using the reverse geocoder as well. So these are different local governments within the city of Christchurch in New Zealand that like we click on the map and it shows you that polygon which corresponds to the local government's boundaries. See, you can do heaps of stuff with these APIs. And as I mentioned before, you can have sort of a batch geocode. You can use a batch geocoder service in terms of doing a 1 by 1. You can pass on an Excel file or a CSV with millions of addresses in it and ask the batch geocoder to do the magic behind the scenes. And as you can see here, it automatically grabs the coordinate for you. And also that number 1 there, that's the confidence of exact matching between the address and the coordinates. So it's between 0 and 1, and 1 means like I'm 100% sure that this is where it is. And the last parameter of the geocoded response is the different category. So this might be a house number, it might be a place, it might be a street, it might be a country, it might be an admin boundary. So it will return it for you based on the output that it provides. Alrighty, so that's the places and geocoding and reverse geocoding section. We're moving on to an exciting topic, which is live traffic. And it's a pretty hot topic because not only you can use traffic as it is to get an idea of what's happening, but it can be the underlying parameter for routing and navigation, for your fleet management, for all sorts of different things, for like power consumption of your electric vehicle, for the fuel consumption during the routing and navigation. So you can consume here live traffic data in different ways. The easiest one is like to basically in your JavaScript API, just create your map and add the layer, default layers, vector, normal, traffic. And in addition, you can add traffic incidents as well. And it drops all the information about traffic, and you can click on them and get more information about each of the road segments. And also, you can get the traffic incidents, like if there's an incident or an accident, or there's a construction or roadblock or whatever. We get this information from highly reliable sources. And you can plan your routes or use this information within your applications. The second approach is to use our REST APIs. You can specify the geographic context using particular tiles you want to access, quad key, bounding box, certain proximity, a corridor, which is essentially a route that you've calculated. It's a set of coordinates in a linear feature, or a road class. Here, technologies, roads are classified as functional classes between 1 and 5. The 1 is the arterial roads, and the functional class 5 are the local roads in the neighborhoods. So you can also access the traffic using these different categories and geographic extents that you can mention. And it spits out the traffic in a traffic ML flow format. So it's all industry and global standard that like we provide the information to. So and this is just an example of getting the flow information for this bounding box. And the API key, I'll explain to you later. You need an API key through your account for this system recognizes you and allows you to use the service. And also similarly, there are REST APIs for you to be able to access the incident data using bounding box, proximity, and all these other different geographic extent sort of parameters that you can use. And these are some examples of the outputs that is produced. For example, there's a short description of this incident. It's a construction site, and it's slowing down the traffic. Another form of accessing this live traffic is to get transparent image overlays. And it's a REST API. You can specify the tile based on the certain location. And you can calculate how these numbers come from the globe's perspective. And you can get that and overlay it on top of your GIS or your other maps in your applications and use them. These are just some videos I prepared for you. So this is going to show you in like traffic incidents in Auckland. And I'm grabbing this, the bounding box of the map that is showing and visualizing and listing and visualizing the location of the traffic incidents. How cool is that? And you can click on them and get more information about each of them as well. Another cool example is that you can combine the traffic information with other services like heat map. So if you're a traffic engineer or like you're a traffic manager or your state emergency service or you're someone that is overseeing the traffic or the road network in your country or in your state or in your local government, or you're a fleet manager and you're watching your trucks going around or your cars and vehicles are going around, if you have this, you will immediately notice where the bottlenecks are, what's happening on the roads, and you can just quickly zoom in and to understand like what road segments are affected. If you can overlay your assets on top of them, it's like, hey, Johnny, don't go that way. It seems that there's a heavy traffic down there. Just use a detour. So that's another cool example that you can grab the traffic information using REST APIs or JavaScript APIs and mix and match them with other services. So that was the traffic part, like ending, and now we're moving towards a more complicated a set of APIs and services within our SDKs, which are routing and navigation. So within the navigation and routing, we have normal routing using different modes of transport like car, pedestrians, bicycle, trucks, and all sorts of different mediums. You can enable and disable traffic in your calculations, as I mentioned before. You can have access to intermodal routing. Like, for example, I want to walk part of it. I want to use the public transport and then use ride sharing afterwards to get to my destination. And also we have information about public transport and transit information, timetables, routes, and all of that you can use that within your calculations. Truck-specific routing, which is an interesting one. I will explain to you in a second. Electric vehicle routing, and more complicated, cool APIs for isoline routing, matrix routing, multiple origin to multiple destination. And within your SDKs, you can have features for offline routing. You can do these sort of use these sort of services offline that you don't in specific areas that you don't have access to internet. So the car and pedestrian routing, just simple routing, you can access them through REST APIs, JavaScript APIs, and mobile SDKs, and it allows you to calculate the routes for cars, pedestrians, bicycles, two-wheelers, and also the transit mode. You can request like alternative modes. For example, you say like, don't just give me one, give me 20, or give me 5 of them so I can choose from. You can choose between fastest route and shortest route, and there's another one that is called balanced. So it optimizes the route based on the fastest and shortest and finds the most balanced way for you to navigate. And also, as I mentioned, you can enable and disable traffic. You can have different levels of preference and avoidances. For example, if you don't want to go through toll roads, you can specify it. I don't want unpaved roads, you can exclude them. Don't want to use tunnels, you can do the same. And if you're doing it by foot, you can also include stairs and park lanes or exclude them, include or exclude them. And if you're using the REST APIs, this is just the output of the API that you can visualize it on a map, as you can see here. And this is a simple API call, which gets the transport mode, origin, destination, what sort of information we want it to return, whether you want to specify the departure time and the traffic, and also the mode, which is the fastest. And also it's asking to avoid certain features, which is the toll road as well. And it's asking for 5 alternatives as well. So just to give you a demo as an example of the routing. So I'm going from 533 Church Street in Richmond to 80 Barclay Street in Brunswick East in Melbourne, Australia. And I want to use different transportation modes to show you how the route changes and how the duration of travel changes as well. So I use bicycle, and these are the 2 addresses. As you could see, the geocoder was very useful to give us the location of these 2. And now I'm calculating the route. And as you can see here, the route using bicycle takes about 37 minutes and it's almost 8K from the origin. If I change it to car and recalculate, the route doesn't change much because the bicycles can, the bicycle and car share the path. But look, there's only 19 minutes of travel time. And if I want to walk it, it's going to take me 2 hours, and pretty much the same sort of route. Yeah, so that's an example of routing that I wanted to show you. At the same time, this is the intermodal, multimodal routing in transit that you can include trams, foot, buses, like walking, metros, and all sorts of different things to go from one place to the other. And it returned like a bunch of alternatives. And as you can see, it's suggesting the first part of the trip to be on foot and then take the train and again get off at a certain stop and walk the rest. So this is just another line of code to give you the information, and you can pass them and visualize them on a map or use the output elsewhere. How cool is that? Like first time I used these services, I was like, whoa, that's great. Yeah, there's so many possibilities. And again, it comes down to the surprise that I have for you at the end. So just bear with me while I go through all these things, and I'll tell you all about that surprise soon. So our APIs also provide public transport information. For example, I type in Melbourne, and so it shows me the location of the public transport, like train stations here in downtown Melbourne. And if I select one of them, which is the Flinders station in Melbourne, it is the most central station in Melbourne, in Australia. And so I grabbed the ID and I clicked on that ID, and I'm searching for all the routes that goes through that station. And I visualized it on the map. And if I click on all these different routes, you'll be able to see this is the train route path, like from Alamein all the way to Flinders Station. And these are all the different stops. And when you click on them, you'll be able to have access to the timetable for each of these stations as well, which is pretty cool. And if you want to build an application that uses the information, like to tell people, help people with their public transport planning, you'll be able to do that. And to complement that, you can get public transport alerts as well, because like we have a close partnership with these authorities. We get information about like what's happening, like alternative routes, like road closures, train problems that you can instantly access, and to complement that route planning as well. Cool stuff, hey? I'm going to move on to the advanced truck routing. Trucks are a little bit different from normal cars or pedestrian or bicycle because trucks are generally bigger in terms of height, width, the length of the vehicle, and the payload that they carry. Some of those payloads can be very dangerous, so you can't navigate through any roads, right? How many times you've seen like hazardous waste sort of trucks are driving around, and like you don't want it to be near a school. If something happens, that's a big liability, right? So at the same time, like at least we experience it a lot in Australia. I'm sure it's the same case elsewhere in the world as well. A lot of the trucks get stuck underneath like the overpasses because the driver sometimes thinks, "Oh, I can make it," and they just try to pass through the underpass, like the overpass, and they get stuck, and the road gets closed for hours for them for the police and other emergency services to arrive and clean up. So in this case, you can specify the route for the truck routing, different sort of payloads, like if it's an explosive, poisonous, flammable, corrosive, and all sorts of things. You can specify the size of your vehicle and also the other options in terms of tolls and tunnels and whether you want to enable traffic and stuff. And it gives you the route. And if you pay attention, I mean, if I had a simple routing for a car, it might not have been the same because there are areas that, for example, legally the trucks can't travel. And also like in terms of the geometry of the truck, those roads are not suitable for trucks in terms of the weight that they can hold, and also the structure of the urban area that like the trucks can interact with. So we have services that are REST, JavaScript, and also within our mobile SDK that you can use to use this. Another cool application is the electric vehicle routing. I was talking to a few folks yesterday, and it's quite an interesting service because it's essentially a car navigation routing. However, because different part of the topography and different parameters affect the consumption of the electric vehicle, and it's like we have limited resources, then you have to be careful in terms of the routing, because somewhere on that route you may run out of charge. So our electric vehicle routing not only gives you the route, but also accounts for ascent, descent, flow speed table, like which is essentially how much consumption you have based on whatever speed, also the traffic speed table, and also it accounts for auxiliary consumption parameter, like if your air conditioning is on or you have your lights on, it calculates the power that you're consuming, and also and then according to that it suggests you the most optimum route, and you can get additional messages about or services about there's a charging station over there and stuff, which I'll get back to in a second. And this is the output of this API call. For example, this free flow speed table is similar to this one. So if you go faster and faster, firstly you gain optimized sort of consumption, and then it drops down, and the consumption it goes up as you start speeding up. And that's the electric vehicle routing. And we also have another REST API, which is pretty cool. It's basically optimizes the route calculation between one or multiple points and other multiple points. For example, I'm standing here, and I have the options to go to this place or this place or this place or this place or this place. What would be the closest one that I can get to in terms of time? And you can include traffic and all sorts of things. And this API will calculate the cost factor, which can be time and or distance, and it tells you which one of them is the closest, or you can make a decision according to this information. It supports for several routing options. Traffic is one of them. You can decide on or choose the mode of transport. And whether you want shortest route or the fastest one between each and every one of them. So for a simple matrix routing, you're limited to 400 routes per second in terms of performance. And the matrix can be very limited, but you don't have limits on the region size, so you can go as far as you want. If that's not enough for you, you're going to upgrade your account and go for a large-scale matrix routing that allows you for up to 200,000 routes per second calculation up to that level. And also it bumps up the matrix size to 10,000 origin to all the way to 10,000 origins, and it creates the matrix for you. And this is just an example of the matrix that it creates. It doesn't come in a tabular format. It spits out a JSON format or an XML, depending on what you request for. And it produces something like this that you can visualize them and create and showcase the routes as well. I'm just going to have a look at this screen, see I'm still online and people are still listening. Okay, fantastic. And the next one is another favorite API of mine, which is the isoline routing. So it basically is an API or a service that calculates areas that can be reached within a particular time and distance from a certain point, which is you can see here, or anywhere else on a map to that point. So it can be distance based or it can be time based. For example, from the middle of from the center of Berlin, I want to drive 5 minutes, or let's say, yeah, like 5-10 minutes, and I want to know how far along the road network I can go. And so you can spit out multiple sort of ranges within one API. So that's 5 minutes, that's 10 minutes, and that's 20 minutes, let's say. And that's the areas that you can cover by 5, 10, and 20 minutes of driving. Or it can be based on distance. Say how far I can go along the road network by just driving for 2 kilometers. And it's not essential. It's not going to be a perfect circle because you're limited in terms of traffic and the road geometry as well. 2 kilometers along the road geometry is not as direct sort of line that it forms a circle. You can have a multi-component isoline. I'll show it to you in a second, and reverse direction isoline as well. As I said, you can decide like from what places I can drive for 5 minutes and get to Berlin. And a perfect example of that can be a component of a ride-sharing application. You request your Uber, for example, and it looks for all the other cars that are within your range, and it calculates these isolines, like where will be the compromised area that this guy can walk and that car can drive, and the algorithm behind the scene matches them in an intellectual way. So how cool is that? And this service is amazing, and it has a lot of different applications. So the polygon can be very complicated and complex. At the same time, you can adjust the level of detail to simplify it for the user. You don't want every meter there's a point that shows like, oh, you can't go there or you can't go here. I'll show it to you in a second. And also you can enable it at particular time. So for example, if I leave 10 minutes from now or 20 minutes from now, how this isoline changes, and also it counts for traffic as well. And another cool thing is that you can calculate this based on certain level of consumption. For example, if I have an electric vehicle and I have this much charge, how far I can go with this, and then you can use that information for planning. So this is an application I developed a few months ago for COVID. That's the 5-kilometer radius, and we wanted to know like how far we could travel. And yeah, as you can see, so the setting is on car trip, and it's an isoline of a distance-based isoline. So that was 5-kilometer isoline, and this is 20-kilometer isoline. And I probably extended. We can go further, or just like shrink it back to a manageable polygon. And I'm going to switch to a time-based. So within 13 minutes of driving, how far I can go in Melbourne. Well, it's a bit unrealistic because I guess traffic is not enabled for this. You can't go that far within 10 minutes, 15 minutes of driving. But yeah, and it shows you the different sort of times of start of your journey and how much time it will take you to go that far. And so the last bit, I extended it to 6.5 hours of driving, and see how far you can go across the states, and just you can end up in New South Wales and somewhere in South Australia as well. So that's just 2 examples of time and distance-based ISO lines. And as I mentioned earlier, you can do the reverse. For example, I'll skip through the video. This is our Melbourne office. And so I'm specifying within 10 minutes of traveling from where I can reach our office. And then in that sense, for example, if I'm looking for a house that I want to live in or buy, and I want to be able to get to the office by 15 minutes of walking, where that needs to be. And that will be one layer for my decision making. There might be price and neighborhood character and all those different things, so you can do satisfy the needs of those kind of applications. What else? I guess I mentioned about the ISO line based on consumption. It's fairly similar to the ISO line, the electric vehicle routing, but it calculates the that ISO line area based on the consumption details and parameters that we provide. I mentioned about multi-range ISO lines, and you can calculate a lot of these ISO lines for different ranges, and it just takes an array of these ranges within the single API call. And you can see here the outer polygon geometry for one. For the second range will be here, and there will be the third one. So you don't need to call and exhaust your API usage over and over by just calling them over and over. You can do them in one. And I guess I mentioned, like, if you're on an island with ferries connecting different islands and you want to go from one to the other, your ISO line will be broken down into multiple ISO lines, as you can see here. And there will be 2 polygons with a connection sort of polyline, as you can see here. So that's a representation of this that we visualized on the map. And you can simplify complex polygons by specifying the maximum number of vertices of this polygon for simplicity. I guess it takes some time and research to understand and figure out what will be the most optimum one for whatever application that you want to use for, or just leave it as default. I guess the last category that I'm going to cover today will be the fleet telematics APIs. We have custom locations, geofencing, advanced data sets, waypoint sequence, toll costs, and route matching APIs that I'm going to talk about today. And these are only a subset of this category. That we have heaps of others that I realize we only have like an hour or so to talk about these things. So I filtered out some of those things. But I'll share the link of their website with you, that you can go and pay the visit to all the other ones. So in terms of the custom locations, when you're using here location services and maps, you're not bound to a specific set of content. You can bring your own content and visualize them and search, and query as well, for example, searching and routing. And we have other sort of data sets that already in this fleet telematics suite of APIs that you can access them only using these APIs and not any other services that we have. As an example, you can search for shapes or points of interest that are located within a given radius around a particular point. So imagine a circle, you're looking for restaurants or whatever in that thing. Or they're located within a buffer along a road that you calculated to see, like, for example, where are the McDonald's or certain shops that are around the certain calculated road between Melbourne and Sydney you're traveling with. More specifically, you can specify like you can search for these features using bounding boxes, and I'm very excited about this particular one, that you can search for shapes and points of interest reachable within a short detour from the main route that you calculated. For example, I'll show you an interesting example later, that you can find petrol stations if you're going from Melbourne to Sydney, and you want to know where these petrol stations are within the vicinity of the route that you calculated. You can do this with this particular API. And also you can search for the road links that are reachable within a short detour from the main route as well. Well, some of the advanced data sets that we've got in this particular suite of services are elevation or height, road slope, road curvature, road roughness, speed limits, and traffic sign for the different road segments that we've got. And these are just like a few examples of them. We have over 70 different layers such these information that you can get the full list from this particular link through our developer portal, which I will send the link to you later. So and that includes admin boundaries, different shops or categories of points of interest, and so on and so forth. You can explore them in your own time. So this is just an example that we developed, like to find fuel stations along the route with certain detour from the main route. Yeah, right. So I want to go from, let's say, Melbourne in Victoria to another city, let's say Bendigo, in the same state in Australia. And I want to say, calculate the route for me. I want to know where are the fuel station along that road if I take a detour, come out of the main route and drive for 3 minutes. And the results are calculated, and as you can see, these are all the road segments accessible from the main route within 3 minutes of driving, and those are the fuel stations that you can access. And it's not just the geometry, there's a whole heap of information that you can gather by just clicking on them, or it comes in that JSON output that the API spits out. Cool, isn't it? All right, another example is an API, a router API, to find the route for electric vehicle and make sure that there are charging stations matching the plug type of my electric vehicle, and they should be along the way as well. And I want to know where I need to charge my EV along the way as well. So let me choose one of these examples between multiple waypoints from Munich to Turin to Marseille and all the way to Barcelona, or vice versa. And if you remember, I mentioned about different parameters for the electric vehicle in terms of the consumption, and also it takes the charging curve and the maximum charge that I want to have when my charging at each station finishes, and the initial charge at the beginning of the journey as well. So, and it calculated a route. Let me just rewind. Calculated a route, and you can see there are like points along the way that it says charging, and they show the areas that like you get to the minimum charge at your stop. So it's 10 kilowatt per hour, and you want to charge and get it to 60 and continue your journey. And if you see, it says by this point you've reached 12.3 kilowatt an hour, and there won't be any charging station up here before you go below 10, and it will take 2 hours 9 minutes to get to the charge of 60 kilometers an hour. And then once you finish, you can continue on, and it goes on and on all the way for you to get to Munich. Cool, eh? And in terms of the data sets, the advanced data set that I mentioned, you can calculate a route and get the elevation or height data for that route, for calculating the elevation profile, for example. And it's not just for a route, you can access it for any road segment. This is the trip from Melbourne to Sydney, and this is the elevation profile. And all these different colors are the height for each of these road segments that you can see, like individual ones, that but they constitute the whole the road. And for example, you can use these sort of information to calculate energy or fuel consumption, or if you're hiking or doing other stuff that you need elevation data, you can use this. There's also information about road slopes. I'm calculating it out. And for example, for each of the road segments, I'm going to stop the video because it's going to give a lot of these things along the route. But for example, this particular road segment slope is 2.92 degrees. And this one is pretty flat. It's only 0.07. And there's another data set that you can access through these APIs, the road curvature. And the perfect use case for this data is road safety. For example, you own a fleet of trucks, and there's a you want to ensure that they don't crash, they don't tip over, or anything like that. So they need to stick to a safe sort of speed, but not always the speed limit is the safe speed. I'm going to show you a quick example here that, like, from Brunswick East in Melbourne, calculate the route to Melbourne Airport. And you see there's a curvature in the road here before you enter the CityLink highway. And the curvature is so much, and I visualized it, that it's suggesting that the maximum speed that you can go is only 47 kilometers an hour, but the speed limit is 60. So if you go 60, it depends on your vehicle, it might not be safe for you. So you can access this information using just one API call. And on top of that, you can get road roughness, and these are up to industry standards as well. These are speed limit information for different vehicles like buses, taxis, cars, trucks, emergency vehicles, motorcycles, and you can access the maximum speed limits for them on that particular road segment. And last but not least, we're looking at traffic signs. If I calculate a route, for example, from Sydney, like downtown Sydney to Sydney Airport, and then it gives you all the information about the number of traffic signals, variable speed signals, road narrows, or no overtaking signs. And you can actually, like, if you're building a navigation app, you can include these things as the driver driving. And if it gets reached to that particular area, you can show the notification that, like, yeah, be careful, or be aware. You can also calculate toll costs as within your application using our APIs. For example, if you're going from Melbourne to Sydney, this is the your vehicle information, and I want to know, like, how much toll I need to pay from downtown Melbourne to downtown Sydney. And you will see here that oops, my bad. What am I doing? Okay, so it shows you that, like, this is the breakdown of the tolls that you need to pay, and overall it will cost 39.41 Australian dollars. And if you also associate driver cost in terms of number of dollars per hour that you need to pay the driver, and also the vehicle cost, this is how much the vehicle running cost is, and also calculates that for you as well. Amazing. Waypoint sequence is another interesting API, REST API that you can use. For example, if you're, Vidam will talk more about this. If you have multiple destinations, you can pass the location to this API, and it will give you the most optimum route in terms of time or distance for you to drive through all of them in the most optimal way. Vidam will talk about it a little bit more. And lastly, I want to talk to you about geofencing. So if you're tracking an asset and they're moving and you want to know, like, you want to set areas that, like, you want to know as soon as that asset enters that area. For example, if you have an IoT device at home, you want to know, you want to let them know that, like, yeah, when I get to within 500 meters of the house, turn on the heater or the cooling system. And you can use geosensing through REST and JavaScript APIs to send notification or activate or trigger a certain function. For example, there's a circle or a bunch of polygons and lines that we created. As soon as the truck goes through them, it triggers a message saying, like, objects is in the circle or it's in the polygon geofence. And you can integrate this with other sort of services. As I mentioned before, we have weather, and it's not just going to tell you that it's sunny or cloudy. It gives you all sorts of parameters for a certain city that you're in or you want to inquire about, like in terms of the comfort level, temperature, the normal temperature, humidity, rainfall, snowfall, wind speed, and wind direction, all sorts of things you can cover as one IoT API call. There's another sort of suite of APIs for IoT, but I'm not gonna talk about it today. I'll leave it for the session, for the webinar in 2 weeks' time, that we will cover the IoTs. So stay tuned and join the other one to learn more about the IoT stuff. We have a iOS and Android SDK, we call it LiveSense, that uses machine learning and AI to detect different features using your mobile device or a camera-enabled device that you have. You can install it, you can customize it, or you can program it to detect different features. For example, if there are cars and pedestrians, traffic lights or traffic signs, and also the brake lights of the cars as well. It automatically detects and it notifies the users for road safety purposes, for example. Check this one out. It's pretty cool. I've used it before. I'm gonna skip the HERE Studio and Data Hub for now, but I want to tell you that for all the major cities in Australia and worldwide, we have opened up a lot of the HERE core data layers, and they include admin divisions, destination signs, hydrography, land cover, land use, places, building footprints, traffic signs, traffic restriction, navigable roads, and all those sort of things that you can download for free. And it covers the entire city. So if you're interested, I'll tell you, we can talk more about it afterwards. And this is accessible through the developer portal, which I will show you the link soon. So all you need to do is to go there, select the ones that you want, the continent, country, and the city. Either you can save it to the data hub of the HERE, which I skipped, but if you're interested, I can tell you more, or you can download them directly and use them within your GIS. And yeah, so I'm done with the APIs sort of introduction. But if you're interested to learn more about them, this is our HERE developers home, developer.here.com. And you can go there and learn about our products and APIs and SDKs, their documentation, step-by-step guides, tutorials, blog posts explaining different things, and all in all, they are there. So if you want to go to the developer portal, use this link, here.is/devs. I'm just going to pop it in the chat. Oh, I revealed the secret too soon. Okay. Now the surprise. So all of this stuff that I talked to you about, you can use 250,000 API calls a month. Wait for it. And also, if you're using our SDKs, you're allowed to use up to 5,000 users per month can use it. And that comes at absolutely no cost, $0. And when you sign up for a developer account to build your applications, unlike the other companies or places that you probably experienced in the past, you do not need to enter any credit card information. Just a name, first name, last name, email address, and your country. That's it. So yeah, go wild. And that was the surprise. $0. Okay, I'm gonna finish here and ask Vidon to take you through an exercise, a hands-on exercise to develop a simple delivery app. Sorry for talking too much, Vidon. I hope I could set the scene for you to be able to take people through the application development process. I'll shut up and I'll leave you to present. Vidon, you're on mute.
Oh, I got it now. Thank you, Sam, for amazing explanation. Hey, everyone. I'm Vidhan, and I'm Developer Evangelist at HERE Technologies, and I'm based out of India. So what are we going to do today here? Right? We are going to solve an age-old problem, which is optimized delivery of your assets, or you have some delivery products that you want to deliver to certain addresses or a group of addresses. What you want to do is you want to have an optimized way in which you take the shortest time, or you avoid the traffic, or you reach in a shortest distance. And that is what we're going to do. We are going to have a bunch of addresses, which are, of course, Australia-based addresses. And we'll have a delivery truck, or we are going to consider a car in this case, right? And then we are going to come up with a solution where we are going to draw a route, which will take us through all these addresses.
First thing first, what you all need is a GitHub complete project, which I have already shared with you. Kindly go through it. And you have two ways. Either you can simply work along it up, which basically your JavaScript IDE that we are using is Visual Studio. Any IDE, it's up to you. Or secondly, you can simply relax, sit back, and watch the magic happen. Okay. First thing first that you all need is to link, right? And it is a GitHub project which is built for the shop. So what are the things that you require? Code and a bunch of setting up into it, go through it. And the next thing that you'll need is to basically have signed up on your developer portal. Let me show it to you really quickly. All you need to do is provide your last name, your email ID, and a password. That's it. And you simply have to check if. And Sam has explained everything in detail. You sign up for the freemium account where you don't need to provide your card. Free. Okay. After this string of, all you need to do is use the credentials and log into it. And here is where we are. All the keys required to work with this particular project. Please sign in, and you will reach the page. Now, this is what we call our developer portal, which is require in terms of location and here. Okay, all you have to do is you have to go through the documentation and all the resources, and you're good to go. What you need to do is you need to reach to your credential page, and the page contains all the credentials which are your unique keys, which will be used your server for calling the APIs, for grabbing the map images. And when you create credentials, you have many options. Either you can go with JavaScript, that is great. You can go with REST API, or if you are into mobile application development, Android, iOS, Flutter. So we are not going to do that. What we need to do is simply create an API key. Click on create API key and copy this API key for us all. Now, I'm sharing my API key and somebody can misuse it. They can, but what I can do is I can simply delete, or the control is totally in our hand in this case. Now, once you key, then the real process starts. We have the, which is basically setting up your VS Code. What we are doing here is we are a static or a web page which is going to show a map, and we want it on a server, right? Because that is what we are working on. So do one thing, simply on the VS Code, if you have it with you, go to, we show it to you and simply search for LiveSense. And this is the live server that you all will be requiring. Simply grab it. And this is what is going to help in showing our web page. Once you're done with this, all you need to do is nothing. You have to create a, name it anything you want, create a file inside index.html, or you can name it whatever you want, but then this that your file should be index.html, right? So that is, I've created a file called index.html. So all the things that we are going to do is going to be using HTML, and we will be playing with JavaScript a bit. You simply have to follow the steps. The first step is quite simple. I'm going to do that. I'm going to explain you what is happening here. The point is, if you want to have the solution, what you want to do is first you want to have show it or see a map. Once you see multiple addresses as a marker or as an icon on a map, and then you would want to see your rate. And after that, you would want to calculate the optimized sequence in which you want those deliveries to be made to all those addresses. And after that, you see a route being drawn to all those addresses. And that is what we are doing today. The thing that we are doing, or which we will be needing, of code, basically script PS here.com links. And these are basically our, right? If you're working with any of the map library for JavaScript, this exists them. So this is quite a standard way of doing it, right? And next thing that we have, HTML is a body tag. Inside the body tag, you have two, basically div tag. The last one is an optional, which you can't, you may or you may not. Now, the first division or div tag is basically for creating our map. And then you have an input button, which is basically an on-click. And this function or this method, whatever you prefer to call it, is show details. It is going to show us the delivery sequence. We'll edit the code further. It is going to show us the route on the map. Now that is the final for. Next thing that you need to do is you need to replace your JS API key with the API key. So I'm going to grab it. See, I have kept it on my notepad. Moving a lot between the screen. So, right. And if you have any queries, feel free to ask in the chat and Q&A, whatever you. And Sam might be able to read it out for me, right? Or we can take it at the end. Query. Next thing that you need to do is we have a bunch of lines of see here. Now these are all JavaScript code, so everything we have kept tag called script, right? Platform, basically we are providing the API key, which is going to help us in authentic on the server, right? Once you have the authentic, we are creating a default layer, a base layer to create map, right? And then we are simply instantiating the map. Now, while you instantiate, the things that you want to do is you want to mention the container to show the map, right? So our container is div, so we are simply providing the ID of it. The next thing that what kind of map you want to see? So you can see a bunch of different maps. By default, you want to see a satellite image. You can have that. You can have a normal day. You can have a bunch of options here. I'll share the link where you can find all those things, or better, I'll show it to you. The next thing that you want to do is you want to create a zoom level. Now, how much you want to see from the top. You want it to be zoomed in too deep or not too that deep, right? You can define it with the help of zoom level. It varies from 1 to 20. Now, in between, in the middle, that is 11. And then we have provided as a placeholder the latitude. Now, since I'm from India, so I have kept it in Bangalore. Okay, so you can change it, right? You can simply change it. I'll show it to you how to change it, as in how to long. Now, one of the very basic thing which I face trouble, I want to grab the latitude longitude of a location. Now, that is a mystery, right? So what you can do, this is what I do. You can go to vigo.here.com. Okay, so it's under maintenance. So we can simply go there and we can grab the lat long of a location. I would have shown you maybe shop, right? When it's up, it should be up soon. Now, the lat long, what you need to do is you need to have the UI, right? When I say the user, I want it to be have a zoom in, zoom out button. I have an option of changing the layer. I would love to do. Apart from that, I should be able the marker. I should be able to move around the map, dragging it, uh, clicking it, holding the click, and dragging it and moving it around. Now, simply save it, right? And what you need to do is once you have that extension of Live Sense or Live Server, sorry, Live Sense is our product, right? Do is next you should be looking out for an option at the bottom right. On that option is to go live, right? Because we have installed and downloaded a local server, and we want our app that we are building to go live on that local server. So click on this to pop up a new window for you, and this window is going to be your local host showing the map that you have just created. Now you can see that this is a very default basic map that you. Now for me it's taking time, for you it won't, right? There are a lot of things happen. You can see that I'm able to drag here. I'm able to move it around, and I can zoom in, I can zoom out. Let's yeah, I can zoom in, I can zoom out, I can change the layer too. For example, I want to see the satellite image, satellite view, I can do that, right? Okay, so these are the things that you can do. So I'm going to default map view. Now, the next thing that you, right, to have a taste of the color, the background, what you can do is you can map. All you need to do, or all you need to have is a YAML file. So the that we want to use is for the dark theme. Now you can find it here, right? Basically, we are setting the style here. Simply copy and paste it here and save it. You don't have to start and stop the server again. You simply have to go to that ring, and it's going to do it for you. So this is the dark theme that we have. Now, if you code, let me get back to the code. If you look at simply calling out a function, and we have as a layer, right? So map is a layer which is on top of your default layer, right? And we are simply providing the link to the YAML file, and we are simply setting it as a style function. That's it. It's so easy to change the style, right? You can have your own YAML file. You can do all those things by yourself. So that completes our one step where we are able to show. The next thing that you would want to do is to have a bunch of addresses which are Australia based. Thanks to Sam, he addresses to me, and we are going to show them as a everywhere, and we're going to see the truck icon or car icon. In our case, we are going to work, right? So let's go back to the next step. Scroll down, go to the step 2. Now on step 2 is simple. You just have to place the marker. Placing the marker, all you need to have is a bunch, right? Now, there are many ways on approaching to the solution. One is you can use our geocoding API where you pass latitude and or you pass the address and then you can pass the latitude longitude to this particular piece of code that you're seeing, right? Okay, and a very good way of doing it, but to keep it simple and to cover the workshop, we are providing the hard-coded addresses or lat long. And you all should also copy this at the top of your script tag inside. So these are the bunch of addresses you are going to work with. Now, the next thing that you would want to do is, first of all, if in Australia, I don't want to look at Bangalore, right? I want to change that. So all you need to do is go to this section and this value is going to be your destinations, and I want to see from the truck. Right. Now, what I'm doing is of my truck. But hold on, right now you won't be able to see the markers because we have not created it. But what you can see is our perspective now. See, my map is pointing now. Right now we are in Australia. Okay. So the next thing that you is scroll down, and you would want to have the image you want to show as an icon on or as a marker. So you can get those images links, home and truck. Although we are using truck, but we are showing the car navigation, right? But I would suggest that you play with this, right? Now, the next thing that is copy this code, and this lines of code are basically place it, drop it here, and then I will explain doing actually. These lines of code, one, the images as an icon. So once you have the icon, you have the reference of an icon, right? Okay, as an icon. What you need to do is you need to put these icons as a marker on a map. And that is what we are putting all the icons as a marker on a map. This is how we do it, right? h.map.marker and provide address or the lat long of and what icon you want as a marker. Home icon as a marker for all the addresses where we the asset or deliver anything that you want, right? Whenever you're delivering, normally you deliver to you or asset to the recipient, right? And last icon, but a different icon. So we are showing it as an image of a truck. And is you need to add all these markers onto the map. So we have map.add object. What objects we add? Markers that we have mentioned till now, right? That is, save it and go back to your image. Let's see if it shows. So, right. So you have a bunch of markers, right? These are 1, 2, 3, 4, 5, 6, 7, 8, 9. And delivery vehicle. Okay. So that completes our see that where we have rendered a map, it's a style, and now we have all the locations as a. Now, what else you can do is you can do, right? If you want to read the addresses, you can simply make it clickable. You can have an info bubble pop the addresses, right? Okay. Next, what you need to do is let's play with it. Right? Once we have the markers, what you need to do next is you need to have in which your delivery vehicle is supposed to travel to deliver all the assets to all the addresses, right? So we are going to calculate the delivery order using what we call here waypoints. Again, simply copy this code and explain to you and copy it completely at the bottom of your script tag. If I'm going too fast or too slow, and please drop in any queries you have function which we which is called show details, which is basically your on-click listener or click event function, which we have already head tag. Here is we are simply making a REST API call. So this is our REST API, address of our REST API, and it is going to return us back a value in JSON, find a sequence, and what we are going to provide here, our API key. So that is our truck's address, and it doesn't matter in which order all the destinations, because we are going to sort it, right? We are going to perform the sorting, an algorithm to sort it out in an optimized way. Optimized way, we're going to sort it out, optimize for time, and what we are going to use here in a shortest possible time frame using car. We have disabled the traffic. What I'll suggest is later on you play with this, you change this cart into truck, or even to have just fun into a pedestrian, right? That will be fun, covering all the locations on foot, right? Okay. Now, you can enable it, but for our use case, we have simply disabled it. Just to show you how the outcome, I have the same call here. Okay, so this is the API that I have. Okay, I'm going to drop the chat so that you all can try it all with me. And for me on your screen. Okay, now when you make this out of India, Bangalore, right? A bunch of information here. You'll see waypoints, you'll see basically how you're going to travel, right? All the points and these. Now here, the order that we have provided was different. Start, then destination 1, destination 6, on and so forth. You'll see a bunch of information. So all you need to do is you need to grab it, you need to pass into it, and you need to get out or take out which is of your importance. And that is exactly what we are going to do. Our VS Code now. Now, all that we have made, now we have to handle the response, and response is handled by the function, which is an amazing function in JavaScript. Although I'm not that good with JavaScript, and Sam helped me a lot with the response, right? Okay, you want to see how the response looks like? Let's have it. Do is I'm going to simply do a console dot log the data to see how it looks like, and then we are going to see or perform a bunch of different tasks on this. Okay, if you scroll down, okay, we are passing the data. We are simply taking out waypoints, and we are iterating through the waypoints, right? The value, the waypoints, and then we are allocating, providing these values of a certain value associated to key called lat and longitude, and that is the major thing that we're going to do, right? So these are very much important, right? And for now, you would want to comment it because we have it show route function, right? So that is something that we need to create, but later on, that's the next step. We would want to see a bunch of, right? So I am going to console the log data, and apart from that, what you can do in console more of the things here, you can simply print it, right? Okay, what else you would want to print? Let's try out the, let's have console.log, and we can have values. That is something which will be to have. And here, somewhere here, to read out the lat long 2, right? That is something that, okay, let me okay, I think this is enough for now, right? Now let's go back and run this. To run this, simply comment out the show route because we have not created it. Otherwise, it will show you or throw you an error. Okay, let's go back to our screen on the console. we have console here. Now I'm going to click on show details. Okay, it's showing me API key invalid because I think API key. So make sure that you're doing that, right? We didn't provide the API. Please provide the API key here. The same API key. I believe we should have created one where should have or provided it twice, right? Let's run this again. Now click on show. Yeah, you can avoid the error from now because it's not able to recognize 0. A small error, okay, but negligible. Okay, so you will see that structure is a bit different. You have the processing time descriptions, how much time it's taking. Error, luckily we don't have any error. And what you're interested, what you are interested in looking at the results. So that is what we are interested in, the result, and you'll see result at points, and it's taken out result, and we are looking at waypoint, and that is what we have extracted here, right? And if you get all the details, now you had to do it all by yourself. So what you would have to do, you would have to write down the algorithm, you would have to compare all the addresses and do a lot of bunch of, and that would have made your code bulky and tough to process. Instead of that, what you do is something API, you pass your parameters, you pass your API key, and all the heavy lifting all is done by here server. And all they do is provide you the output. And this is how what output looks like. So you have, this is the where we are going to start, then we're going to one, then we're going to destination. See, you have the sequence here. So you have 0, 1, 2, 3, and so on, right? And you can calculate the estimated. We have not done that. You can also mention the estimated time of departure. We have not done that. We are simple. Let's say that you're traveling in any day of time, right? Okay. Now, you have data, right? The length of the data that you got is 11. You can explore. It's up to you. It's only that the same JSON is being explored more better way. Now, once what you need to do next is you need to provide that sequence, and you need to carve or create a route out of it. And that is we need to create a route out of it. This is again something else, right? Copy this code. Copy it and simply paste it at the bottom. Right? Make sure that you are uncommenting show route, because we are copying and pasting is basically show route method. Now this is a method that we call show route. Now this is being called on the event listener. It takes two value origin destination. Now on the above, we are basically origin and destination in variables, right? And then we are passing out these variables into this show route, right? Okay. Now the first thing that you'll see is your variable router. What is it that you're looking at here is our API version, right? Using routing API version 8. Now, inside the show route function is you need to provide your parameters. Now, guys, we are not making our traditional, right? We are using the JavaScript library, and we are passing parameters to that, right? Okay. So parameters are routing mode. We want to reach the fastest, of course. Transport mode, car, but you can change it. You can change it into a truck, right? And that is something that you should. Where we are going to start, we are going to simply go. We have iterated to the complete addresses, right? So we are going to grab the lat and long of the first one and have the destination. And same thing, see, this is your routing parameters, right? Now, if you look at the code, I have again created this. I'm going to share this with you all. And me for showing myself twice or in an exception way. Okay, along, right? Simply paste this link into your browser and you'll see the. Now, we are making the same call, but using or REST API, hit send. The response, see the values that we are passing is API key, transport mode, origin destination, you can change it. This is, I think, in Germany right now. Return action is what we want is polyline, and we also want instruction, something that you can try it out. How much time it's going to take, what is the length, it's going to be 1.206 kilometer. And instructions, how do you want to reach that location, right? So that are routing API return, a very basic one, right? You can do a whole bunch of explain quite beautifully, but we have to keep it simple, easy to work with. You can try it out, these the response, and now code. Once you have created the parameter, you need to go through the callback, right? So we have function which is called on whistle, or basically function, right? And we are making sure that route, and simply we are creating a line string that we would want to show as a single line. Okay. Now you can simply skip it because we are already doing at the next thing that you're doing is you're creating an outline for route polyline, and you're defining how that outline is going to look like, right? Be a color scheme, you can simply define it. You can change, right? And then you have to create a pattern polyline. This is basically the first one is creating a line, right, of covering all the locations. The next one is basically creating an arrow, right? You can change those things, right? We are defining it of an arrow. My bad. Right. We are defining how you want to see it, line dash. How do you want to see that? So we are defining line. Um, Now, later on, we are simply adding those things to route line variable, or we are putting it function of map, right? And then we are adding all map, and simply we are seeing it from a perspective, and the perspective is to be from a certain location or in a certain bound. We are not defining it; we are default bound, right? And simply, and lastly, we are simply calling all these things. You can say that calling the route calculation function, which is or give the callback. And in case if you hit any error, it's going to also an error message to simple. And I think I don't need to. I'm going to refresh this so that I can see a complete map on. And now hit show it. Now something is happening. Let's wait for it. Now it or might work slow and fast for you, but for me it's working slow because on my system. So I apologize for that. If you zoom out, you need to zoom out, right? Okay, because we have not set the from where we want to see this. But let's wait for it to zoom out again. Let's zoom. And all the routes. This is how you can solve the conundrum or the problem of delivering. Now, what organically is the next step that should come to you? The next step, you get the routing instructions, how you want to proceed, or you want to head north for 500 meters, then head or turn left, then move for 1 kilometer. All those instructions is something that you can also do that, but we are not going to show it or do it workshop, but certainly we are going to show it to you in the coming workshops. Right? So hang on for our next workshops. And yes, this is what we have here. Simply scroll and adjust it. Now I'm going to do it a bit slowly. This is where our truck is. Okay, so that is what our example is. Feel free to ask any queries you have, or if you have any queries later on, you can simply chime us, drop us, or visit our Slack and some queries. Let me go back to
Thank you very much, Vedant. That was a very useful demonstration of our APIs and how to create a simple delivery app. I don't want to take much more of people's time. I just wanted to remind you guys about the next webinar that we're going to run next week on the 19th of November. And it will be about what happens when an artificial intelligence meets location. I will be a case of an image recognition. And we want to show you how you can integrate HERE location services with the IBM image recognition and cloud. For the noise, you want to, yep. Okay, cool.
Yeah. Yeah, I can talk about a bit about that. It's basically your pre-built model where we are able to simply recognize the food image and we're able to same food nearby you, right? Say for example, you of a burger on your desktop, on your mobile, you want to upload it, you want to provide your location. This particular piece of code is going to search the who serves that particular food.
Yeah, definitely.
Machine learning.
All right,
and
so
AI,
next
basically, but that
week,
is going
same
to be behind
time,
the scene,
5
which
to
is
7
happening on the
p.m.
IBM
Australian
server. You
Eastern
don't have to worry
Daylight
about
Saving
that.
Time, so Melbourne, Sydney times, GMT 11, if I'm not mistaken, or 10. Yeah, and with that, we're gonna close the session and answer any questions that you guys may have. So if you have any questions, please pop it in the chat. And yeah, and we can answer any questions that you have. Yeah, and if you feel like your questions may take longer and you want to get a proper answer, that more comprehensive answer, please feel free to drop us an email. Our email addresses are on the screen. That's me, that's Vedant, and that's developer Steve, and we can answer any questions that you may have. I'm a bit conscious of time. We're almost 7 minutes over time. And yeah, I guess there is a question somewhere. Okay. Yep. It doesn't seem that like people have questions. So with that, I'm going to close the session. Thanks to Vedant, to developer Steve, and developer Ali from IBM also joined us. Thanks, developer Ali, for spending time and watching and managing this platform for us, well, in the absence of developer Steve. And yeah, with that, we're gonna close the session and go and see you guys next week. Thanks for joining us today, and take care. We'll see you soon.
Thank you, everyone. Take care.